All right, let's dive into something really fundamental today. We're talking about the plumbing of modern digital systems, message brokers, and event streaming
Yeah,
platforms.
terms you hear thrown around a lot.
Exactly. And knowing the difference, really understanding them is, well, it's crucial if you want to make sense of how data actually moves around these days.
It really is the backbone for so much, from real-time fraud checks to, those movie recommendations that just pop up.
Right. So, our mission for this deep dive is to really unpack the key distinctions. We're looking at message queues, think Amazon SQS, ActiveMQ,
The
RabbitMQ,
more traditional players, in some
and
ways,
contrasting those with event streams, things like Amazon Kinesis, Apache Kafka, Google Cloud PubSub, NATS.
which operate on a pretty different philosophy.
We want to explore their strengths, maybe some surprising limitations too, and really help you figure out how to pick the right tool for what you need to do.
It gets interesting when you see why they're different.
Okay, let's get into it. Maybe start with the basics. What exactly is a message broker in this context?
Well, at its heart, a message broker is like a middleman, an intermediary. It translates messages between senders and receivers.
So they don't need to talk directly.
Precisely. It decouples applications, makes sure communication is reliable, and like you said, we're focusing on those two main flavors, stream-based and queue-based.
Let's tackle queues first then. The one and done approach, as we called it. What's the core principle there?
Think of it like a temporary to-do list, maybe a digital one. Producers, they send tasks or messages. The broker puts them in a queue.
Okay.
Consumers then come along and grab those messages, usually in the order they arrive, first in, first out, or FIFO.
And the one and done part.
That's the critical bit. Once a consumer successfully processes that message and tells the broker, I'm done, the message is typically deleted, gone.
It served its purpose, task complete.
Exactly. It ensures that specific piece of work is handled once.
That makes sense. So thinking about managed services, Amazon SQS Simple Queue Service seems like a classic example. How does the standard version fit this model?
SQS Standard fits perfectly. It's fully managed, which is a huge plus. You get practically unlimited throughput for reads and writes without messing with servers.
But it makes a trade-off on ordering, right? Best effort.
Right. Strict order isn't guaranteed, which is what allows for that massive throughput. It also handles scaling. Consumers think Lambda functions or EC2 instances automatically based on queue size.
Oh, that's handy.
Yeah, and it has built-in dead letter queues, DL queues, for messages that just keep failing. Isolates the problems.
And it can do publish subscribe, kind of.
Sort of. Not natively like a stream platform, but you can integrate it with Amazon SNS, the notification service. SNS fans out a message to multiple SQS queues, achieving that pub-sub pattern.
Okay, so SQS Standard is great for high throughput auto-scaling when strict order isn't paramount. But what if it is paramount, like for financial transactions?
That's where Amazon FIFO's QS comes in. FIFO for first in, first out. It extends the standard service, but guarantees strict ordering.
How does it manage that without sacrificing all the performance?
It's clever. It guarantees order within defined logical partitions, which AWS calls message groups.
Message groups, okay.
So imagine you need to process all updates for a specific user and order. You'd use the user ID as the message group bit. All messages for that user stay perfectly sequential.
But different users can still be processed at the same time.
Exactly. Different message groups are processed in parallel. So you get ordering where it matters, but you maintain high overall throughput by processing unrelated groups concurrently.
That deals with the poison pill problem better too, right? A bad message.
It does, significantly.
Mm.
If a message fails repeatedly in one message group, it only blocks that specific group. Other groups keep processing just fine. It contains the blast radius.
And the throughput is still decent.
Oh yeah, it can hit up to 9,000 messages per second in high throughput mode.
Yep.
You just need to think carefully about how you define those message groups.
Makes sense. Now, moving away from AWS for a moment, what about open source options? Apache ActiveMQ comes up a lot.
Right, ActiveMQ. It's a mature open source broker written in Java. Big strength is its wide support for different languages, Java, C#, Python, Ruby, you name it, and protocols.
So good for integrating diverse systems.
Definitely. It integrates well with frameworks like Spring too. It offers high-performance clustering, caching, message persistence, lots of solid features.
Any downsides?
Well, being open source and self-managed, the configuration and management can get complex. Achieving really high availability and fault tolerance often requires more manual effort compared to a managed service. The built-in tooling for monitoring might not be as robust either.
Okay. And the other big open source one is RabbitMQ. How's it different?
RabbitMQ, written in Erlang, is known for being really good at complex message routing scenarios. It has a flexible routing engine,
And protocol support.
also strong. Supports AMQP, MQTT, JMS natively. It's very reliable, too. It confirms persistent messages only after they're safely on disk.
I heard they added something Stream-like recently.
That's right. They have a newer streams feature. It adds append-only log capabilities, making it behave a bit more like Kafka or Kinesis in some ways.
Interesting. So you can mix traditional queuing and streaming.
Yeah, within the same broker, which offers some interesting possibilities. It shows how the lines are blurring a bit.
Okay, so that covers the one-and-done queue world pretty well. Discrete tasks, single consumption, eventual deletion. Let's pivot to the other side. Event streaming platforms, the always-on data flow. What's the fundamental shift here?
The big shift is thinking about data as a continuous, unbounded flow. Events happen and they're recorded. Messages go into topics or channels.
And unlike queues,
Unlike queues, multiple consumers can read the same message independently. And crucially, the messages aren't deleted after being read. They're retained for a configurable time, days, weeks, even indefinitely.
retained, so you can go back.
Exactly. You can replay events, perform historical analysis. These platforms are really designed for real-time processing, transformation, and building this immutable log of what's happened.
An immutable log. That sounds powerful, like a permanent record rather than a temporary task list. So in the AWS world, that brings us to Kinesis.
Right. Amazon Kinesis isn't just one thing. It's a whole suite of managed services for real-time streaming data. Think IoT data, logs, quick streams, even video.
And it scales using shards.
Yep, shards. They're like scalable partitions that distribute the data load. You add more shards to handle more volume.
What are the main parts of the Kinesis family?
You've got Kinesis Data Streams, the core ingestion service, scalable by adding shards. Then there's Kinesis Data Firehose.
Firehose. That's for getting data into storage.
Yeah, it makes it super easy to load streaming data into S3, Redshift, OpenSearch, etc., often with built-in transformations and batching. Makes ETL simpler.
Okay.
The Kinesis Data Analytics lets you run the SQL queries or Apache Flink apps right on the streams in real time.
Real-time SQL? Nice.
And finally, Kinesis Video Streams, which is specialized for, well, video and other time-encoded data.
So the benefits seem clear. Real-time speed, often sub-second latency, massive scale, high durability, with data replicated across availability zones.
And retention up to a year now, which is significant. Plus, multiple consumers can read independently. And, like Kafka's partitions, ordering is guaranteed within each Kinesis shard.
Got it. Now, the big one in the open source streaming world, Apache Kafka. Developed at LinkedIn, right?
That's the one. Kafka is a high-performance distributed event streaming platform. Its whole architecture is based on this idea of a replicated, distributed, append-only commit log.
A commit log, like a database transaction log almost.
Sort of, but designed for massive scale and distribution. You have producers sending data, consumers reading it, brokers storing and serving it. Data goes into topics.
Which are split into partitions. You mentioned partitions are key there too.
Absolutely key.
Yeah.
Partitions allow Kafka to scale horizontally and process data in parallel. But just like Kinesis shards, ordering is only guaranteed within a single partition. Different partitions can be processed concurrently.
So similar ordering guarantees. What about coordination? Didn't Kafka used to need Zookeeper?
It did, historically, for managing cluster state, leader election, that sort of thing. But they've been working hard to remove that dependency with something called Craft, which simplifies operations quite a bit.
Good to know. And the big draw for Kafka, besides speed, is that retention and replayability, right? That immutable log idea again.
That's arguably its killer feature. Messages are retained. Default is 7 days, but you can configure it way longer, even indefinitely with things like tiered storage. This lets consumers rewind and reprocess data.
Which is huge for debugging or building new applications off old data.
Exactly. It unlocks use cases traditional queues just can't handle.
But what about that poison pill problem we discussed with SQS FIFO? How does Kafka handle a message that causes a consumer to crash repeatedly?
That's a critical difference and potential drawback for certain patterns. In Kafka, a poison pill can block processing for its entire physical partition. All subsequent messages in that partition get delayed until the issue is resolved or skipped.
Ouch. So one bad message can halt a whole lane of traffic.
Potentially, yes. It's a design trade-off. Also, Kafka's scaling is tied to the number of partitions. Adding more consumer instances than partitions won't necessarily speed things up for that topic.
But it does offer exactly once semantics.
Yes, which is crucial for things like financial systems where you absolutely cannot process an event twice or miss it. It requires careful configuration on both producer and consumer side, but it's achievable.
Okay, quickly touching on a couple of others. Nats, written in Go, focused on performance.
Yeah, Nats is known for simplicity and speed. It makes a clear distinction between core Nats, basic, fast, pub sub,
Lightweight notifications.
kind of, yeah. And then Jetstream, which is an optional persistence layer built on top. Jetstream adds the streaming capabilities. Retention, replay, queues, exactly. Once guarantees, you opt into the complexity.
And Google Cloud PubSub, how does it position itself?
PubSub aims to blend the scalability of Kafka with some of the features of traditional brokers like dead letter queues and filtering.
Its main differentiator.
It uses per-message parallelism. Instead of assigning whole partitions, it sort of leases individual messages to subscribers and tracks them. This can maximize parallelism as you aren't limited by the number of partitions. It's really geared towards service-to-service communication within the Google Cloud ecosystem.
Okay, we've covered a lot of ground on the what and how. Let's get into the why, choosing the right tool. What are the high-level takeaways on strengths and weaknesses?
Broadly speaking, message queues shine for discrete tasks. Think asynchronous job processing, decoupling services where one message needs one consumer, maybe complex routing. They're often simpler to manage for smaller workloads too.
Good for managing individual work items, making sure they get done.
Right, whereas event streams are built for high-volume, continuous data. Think IoT sensor data, click streams, real-time analytics, event sourcing where you need that immutable history, log aggregation.
So scale, speed, and that historical record are key for streams.
Definitely. They offer better scalability and performance for those massive, ongoing flows.
How does this map to common design patterns? Let's talk about the command pattern, first asynchronous task execution.
Okay, the command pattern. You wrap up a request, an action, as a command object. Send it off asynchronously. Great for reliability, smoothing out traffic spikes.
So multiple sources might send commands, but they usually go to one logical place, right? Processed by competing consumers.
Typically, yes. You need good throughput, you need consumers to scale up and down automatically, and critically, you need good isolation for those poison pills.
So which tool fits best?
Based on those needs, SQS Standard or FIFO are often excellent fits. The auto-scaling, the way FIFO isolates poison pills to just one message group that's perfect for commands.
And Kafka.
Generally less ideal for this specific pattern, mainly because of that risk of a poison pill blocking an entire partition. You don't want one user's bad command to stop processing for potentially many others sharing that partition.
Makes sense. Okay, next pattern. Event carried state transfer, ECST. Data replication, basically.
Yeah, where the event itself carries all the data needed for other services to update their own view of the world, reduces direct calls between services, makes things more resilient.
Characteristics here. Single source, usually, publishing to many destinations.
Right, so native PubSub is essential. Poison pills are less common, maybe, but you often need strict ordering and efficient batch processing to keep all those replicas consistent.
The fit seems obvious here.
Apache Kafka is almost purpose-built for this. Native PubSub, great batching efficiency, strong ordering within partitions, it excels at reliable data replication.
Perfect match. Okay, last one. The event notification pattern. More lightweight.
Much later. Service A just notifies others that something happened, maybe sends an ID. Consumers then fetch details if they care, promotes loose coupling.
Needs pub sub again, probably auto-scaling consumers, poison pill isolation.
Yeah.
Sounds a bit like the command pattern.
Similar needs, yes. And this pattern really shows where you might combine tools. SQS could work for some consumers, but using Kafka as the central publisher for all notifications has huge benefits.
Why Kafka as the publisher?
Because you get native PubSub, you get replayability inherently. Then, if a specific consumer needs queue semantics, it can pull from Kafka and maybe push to an SQS queue via something like EventBridge.
Ah, so Kafka acts as the main event bus, the source of truth, and downstream systems can adapt as needed.
Exactly. It standardizes publishing and gives you powerful options later, like easily sending all events to a data lake for analysis just by adding another consumer to Kafka.
That flexibility is powerful,
Yeah.
and we see companies really leveraging these strengths in the real world.
Absolutely. You mentioned Kinesis earlier. Look at Vanguard using it for cross-region data replication. Disney Plus handling billions of events for recommendations.
VMware Carbon Black ingesting petabytes daily for security analytics. LaunchDarkly hitting incredible scale and durability for feature flags.
And on the Kafka side, Goldman Sachs using it for real-time threat detection in their SIEM. Netflix tracking user activity for personalization.
Pinterest's recommendation engine. Sky TV processing set-top box data. The use cases are vast.
They really are. And underpinning many of these, especially for Kafka, is the rise of managed services.
Right, taking the operational pain away. Companies like Avon for Kafka, or Google Cloud with PubSub, IBM with event streams.
Exactly. They handle the scaling, patching, uptime guarantees. Avon quotes 99.99% for Kafka. It lets teams focus on the application, not the infrastructure plumbing.
It's also interesting how some companies evolve. You hear stories like DoorDash or AppDirect starting with, say, RabbitMQ.
And then migrating to Kafka. It happens a lot.
Why the shift usually?
Almost always driven by scale, reliability, and performance needs as data volumes explode.
Well,
Migrating isn't trivial, but the long-term benefits of event streaming for those high-volume real-time systems often justify it.
but it's not always a replacement, right? Sometimes it's about using both.
That's often the most powerful approach. Use an event stream like Kafka as the central nervous system, the main data backbone. Then, route specific events to message queues like SQS for specialized task processing, where queue semantics are a better fit. Use the right tool for the specific job within the larger flow.
So wrapping this up, we've journeyed through queues and streams. It's really clear the choice isn't about hype. It's about deeply understanding what your application actually needs.
Is it discrete task distribution with auto-scaling, like a queue offers? Or is it about building that continuous, replayable flow for real-time insights, which is where streams excel?
Queues, at their core, deliver tasks reliably, one at a time. Job done.
While streams build that enduring, ordered record of everything, they turn your data flow itself into a queryable, replayable asset.
As we all deal with more and more data, it really makes you think not just about what data you have, but how you manage its flow. That flow really defines the resilience, the intelligence of your whole system.
Absolutely. What insights are still locked away in those flows, waiting for the right architecture to unlock them?